Yes, good morning, my friends, my PUC second year friends. Little gap, we are starting. I have completed what? Inverse trigonometric functions. Nearly double digit, my friends, around 10, 11 videos we have done on inverse trigonometric functions, my friends. Done in detail. I have done many examples taking from your textbook in CRT, or you can say CBSE, your textbook. I have done more than 90% of all examples given in your exercise. Even while doing, I have done some examples, good examples from miscellaneous. Even I have done from your solved examples also, if they are good examples, my friends. All right. Now, once again, I welcome to my channel, Belagali's classes. After finishing what? Inverse trigonometric functions. Next choice of your syllabus portion is the very important portion of what PUC second year is the main calculus, my friends. So now I will start with calculus. It has a very lengthy innings, my friends. In calculus, to the point of your exam, board exam I am talking, even for CET also. Board exam, my friends, 1/3 of the question paper is with calculus. 1/3, what do you mean? If it is 100, your paper is what? 100 marks paper. 1/3 is around 34 marks from calculus, my friends. 34 marks from calculus. Yes. It is a very lengthy innings, my friends. Yes, my friends. This calculus is not starting this year, second PUC, but already while you were in PUC 1, PUC first year, part of it is done. These are the main branches in calculus. This is limit of a function. Henceforth, instead of writing like this, the lengthy word, I write it in brief. This denotes what? Function. Second, continuity of a function, derivative of a function, integral of a function. These are main, my friends. Again comes what here? Application of derivatives, application of integration or integral calculus. Yes, my friends. This limit of a function almost you have completed where? In PUC first year. Even connected with continuity as well as derivative. Related with these two, continuity and derivative of a function. Part of it you have completed in PUC first year. Part of this continuity, the basics. Even part of what is derivative of a function, definition, the basic derivatives of your functions, algebraic functions, exponential functions, trigonometric functions, logarithmic functions, all you have completed at PUC 1 basics. We have to start here in between, even continuity also have to start this. Okay, my friends. So this part is completed. Yes, there is no need to start once again this limit of a function. But my friends, these are one by one connected. Continuity depends upon what? Limit. Then it needs, yes, one by one they are connected. Just they are like a chain. If you know the limit, you can understand continuity. Then derivative. Limit is the main. It is the main section, part of what your calculus. Without limit, no, nothing else in this, my friends. Therefore, continuity derivatives of a function mainly based on what? Limit of a function. If you know this, you can. Then integration or integral of a function directly depends upon what? Derivative of a function. Therefore, all these four topics are connected, internally connected. The internal connection. Yes, my friends. Even though these are the things done at PUC first year, once again, certain things we want here. Those certain things, those basic things done in limits, next in continuity, all the basics by taking some time, my friends, I will explain it. Why? That basics definitely helps in understanding what? The present. Continuity of a function first, then I will start with the derivative of a function, then integration. Already it is completed in PUC first year. I have to start with continuity of a function, because in this you have one example under 4-mark question. For the board exam, it comes where? It comes in part E, 4-mark question. Part E, the last question. You have one example of this under 4-mark. Rest man, it is interest, but by the PUC board, according to the scheme allotment, this has one example under 4-mark questions. Yes, my friends. Okay, I will explain one by one the basics first, then finally I will come to continuity of a function. Yes, my friends. Actually, the meaning of this calculus is calculation. The meaning of this calculus is calculation. When the calculation comes, my friends, calculation of what comes? Calculation of things. Things means what? Quantities, objects. If you take with the quantities, especially in calculus, the mathematicians connected with two types of the quantities. One is constant quantities, or simply it is called as what? Constants. Yes, my friends. What is another one? Another one is a variable quantities. Variable quantities, or we can say them as what? Simply variables. My friends, what is calculus? Calculus, the meaning is calculation. Calculation of what? Calculation of things, calculation of quantities, calculation of yes, my friends. Here in quantities you have two types of the quantities. One is constant quantities, or simply we can call them as constants. Another is variable quantities, we can call them as what? Variables. My friends, variables. Yes, you are observing constants 7 days in a week. Always, when I myself is like from my very earlier days to now, it is what? Same, 7 days. 12 months in a year. Connected with mathematics, the values of pi, value of pi, this pi, then exponential constant e. All these are constant quantities, my friends, constant quantities. In these constants, you can name them two types here. This is two types. One is arbitrary quantities. Arbitrary quantities. Arbitrary quantities or constants, arbitrary constant. And another is this is one arbitrary constant. One more is absolute constant. Absolute constants. See, constants, what is the meaning, definition of constant? It is a value never change during mathematical calculations, during all these years, man, 7 days in a week, that 7 never changed, that 7 is a constant quantity. 12 months in a year, that 12 never changed. Like this we can observe so many things in nature, so many things in nature. In constant quantities, my friends, there are two types. One is arbitrary constant, another is you can say it is a absolute constant. These arbitrary constants are what? Temporary constants. These are temporary constants. What are the temporary constants? To use, okay, I can use what? A is a constant. Another friend wanted what? B. Another C. Another is K. These are what? Temporary constants, my friends. Even while moving, connected with your speed of the vehicle, the speed of the vehicle changes. I may move with a 5 km, 10 km, that 5, 10 are all constants. With respect to the time is there, my friends. This is what comes with kind of arbitrary. Then come to the absolute constant. Absolute constant means it is a permanent constant. Permanent constants. What they are? Permanent constants means these numbers, my friends. 1, 2, 3, 4. What? These are permanent constants. Permanent constants. Yes, my friends. Constant, a quantity never change its value. A quantity never change its value. Such a quantity is called as constant quantity or constants. In case of constants, you can observe two types. One is arbitrary constant, another is absolute constant. Arbitrary means temporary, like this man. Absolute, permanent constants. Yes, my friends. This is about one type of quantity. That one type means it is a quantity which never change its value during mathematical calculations or during certain observations. It never changes its value. It always fixed, remains the same. Such a quantity is called as constant quantity. Yes, my friends. Coming to the another type of quantity, that is called as what? Variable quantity or variables. Variable means that itself tells. What is it? It is a quantity which changes its value. It is a quantity which changes its value during mathematical investigations or with a related situations. It will change what? Its value. A quantity which changes its value, that type of the quantity is called as variable quantity or simply variables. Even in these variables, my friends, you are observing two types of the variables. Two types. One is independent variables. Independent variable or variables. What is second one? Second is dependent variables. Dependent variables. So in case of variables, there are two types. One is a dependent variable, one is a dependent variable, another is independent variable. Yes, my friends. Even though the value changes, while changing the values, my friends, you can observe what? Two types of variables. One independent variable, another is dependent variable. These things, man, I will explain with the help of what? Example. Then in mathematics, very important is what? Their symbols. Normally, my friends, constants are denoted. Normally, constants are denoted by the letters A, B, C, K, like this, my friends. These are the letters to use what? Constants. In case of what? My friends, variables, we use these letters. What they are? One is X, another is Y, Z, U, P, W. One more is there, my friends, T. These are the main 7 letters. Main 7 letters we use to denote what? Variables. To denote variables. Mainly X, Y, Z, U, V, W and T. Yes, my friends. Okay. Variables as well as what? Constants. Next, here man, we referred limit of a function, derivative of a function, continuity of a function. For everything man, this is the main person in calculus. What is it? Function. We must see after defining variables, constants, what do you mean by function? What do you mean by function? Yes, friends. What do you mean by function? Yes, I said, I will repeat. Calculus, calculation of quantities. There are 2 types. One is constant, another is variable quantity. What do you mean by constant quantity? It is a quantity which doesn't change its value. It is always same, fixed. Its value is fixed. Such a quantity is called as constant quantity. I told examples are also given. And what are the symbols? A, B, C, K. These are the letters. Normally we denote C and K, mainly C and K, any letter. Then another quantity is what? Variable quantity, or simply we name it as what? Variables. In this, dependent, independent variables. These are the letters to denote what? Variable quantities. For example, for a variable, we can use what? Very popular example is population of India. That population never be same. Always it is changing. That population of India represents what? A good example of what? A variable quantity. Yes, my friends. Next comes about function. Very important definition. Function. While defining this function, I take one example. That example is area of a circle. Area of a circle, my friends. What is the area of a circle? I denote area as A. This area of a circle is given as what? Pi r square. This is area. What is this? It is a radius of the circle. This denotes area of the circle. This is radius of the circle. What is this, my friend? It is a quantity which is always constant. It is a constant quantity. Yes, my friend. What I do? I give values for r. As what? Put r equal to 1, 2, 3, 4. That's my friend. So when r is 1, I am changing these values. When r is 1, what about a? It is pi. Why? 1 square is 1. When r equal to 2, what is the value of a? This is 4 pi. Area means a square unit. When r is 3, my friend, what is area? 3 means it is 9 pi square unit. When r is 4, what is your area? Is 16 pi square units. My friends, it is a continuation changing. Tell my friends, what is your observation? Observation is we are changing the value of r. But when as r changes, automatically area changes. See, when r is 1, a is 5. When r is 2, a is 4, 5. When r is 3, 9. Like that, we are changing r, but automatically area changes. We are not changing the value of area. We are changing only radius, but automatically area changes. Yes, my friends. From this what is clear? From this what is clear? With this equation, area of a circle depends on the values of what? Radius of a circle. This is change. Change is a variable. What kind of the variable? It takes what? Independent values. Then the values of r, you can tell them as what? You can say what? It is a independent variable. Radius of a circle is an independent variable. As r changes, area changes. Therefore, in this equation, this area of a circle is a dependent variable pi. Again, you are observing the change. Values of a are changing. Change means variable, fixed means constant. Fixed means constant. Yes, my friends, once again I repeat, as r changes, area changes. R is known as independent variable and area is known as dependent variable. And what is your one more observation? See here, pi. It is a fixed. It is fixed in this case. What? This pi is a constant, whereas these are the numbers which are changing. Area changes. Yes, my friends. Radius is a independent variable, whereas area is a dependent variable. In this case, ma'am, r and a. What is your r? R is a independent variable. What about your a? A is a dependent variable. What is the relation? As r changes, a changes. R changes, a changes. This relation means what? As r changes, a changes. In this case, we tell area of a circle. Area of a circle. My way of writing the circle, my friends. Area of a circle is a function. Of its radius. Its radius or radius of a circle. Radius of a circle. Instead of writing this area of a circle is a function of radius of a circle, we write this in symbolic way. Area is what? It is a function. Yes, see here. Area is a function of what? Radius r. Function of radius r. Therefore, a is a function of r. This is how we denote, we introduce what? What do you mean by function? Function. In this case, what? Area of a circle is a function of its radius, written symbolically as what? A equal to f of r. This f of r, it is not f into r, it is f r, one symbol to denote what? Function of r, function of radius r, function of r. Yes, my friend, this is how the mathematicians introduced what? The meaning of word what? Function. In this function, there are two variables. One is dependent, another is independent. And always, dependent variable is a function of independent variable. Yes, my friends. This is independent. What is this? This is dependent variable. Yes, my friends. I gave this one example just to introduce what? What do you mean by function? Like this, even you can take what? This is a rectangle. This is a rectangle. It has what? Length and breadth. This is breadth. What is this? A. What is the area? Area equal to length into breadth, my friends. Length into breadth. Yes, as L changes, A changes. As B changes, A changes. As L and B changes, A changes. In this case, area of a rectangle is what? It is a function of two variables. Pi. The value of length changes, value of what? Breadth changes. Therefore, in this case, what? Area of a rectangle, area of a square, they are what? Functions of two variables. Even if you take this is x, my friend, this is y, in that case it becomes what? It is a function of x, length, y, breadth. Function of two variables, x and y. In this case, only one variable, two variables. Like that, my friends, You have volume, this, that. It comes what? More than 2 variables. Yes, my friends. Then it is a definition of what? While giving the definition of this function, you need what? One must be independent, another must be dependent. I take what? Y as a dependent variable and x as independent variable. If the value of y, see, the value of area, A depends on R, my friend, radius. A depends on R. If the value of y for its value depends on x, then this variable y is called as, my friend, function of x. It is called as what? Function of x. Symbol y equal to fx. My friends, it is a symbol to denote what? Function of x. It is an independent variable. This is dependent variable. Yes, my friends, it is an important definition in calculus. Why? For everything, I told in the first itself, I wrote what? Limit of a function, continuity of a function, derivative of a function, integral of a function. Without function, there is no calculus. Always, all these with what? Function. Yes, my friends. Yes. I give in one word the definition of function. Yes, my friends. This example, everything made clear. What is function? What is constant? What is variable? The types of constants: arbitrary constant, absolute constant, function. Two types of variables. What are the two types? One is dependent variable, another is independent variable. Yes, my friends. In one line, definition of a function. Yes. If the variables x and y, it is a definition of a function. If the variables or two variables, x and y are such that the value of y depends on the value of x, then we say that y is a function of x. Y is a function of x and is denoted or written and is denoted as y is a function of x. And read this as what? Y is a function of x, written as symbol y equal to fx. My friends, here y is a dependent variable. Here y is dependent variable. And x is independent variable. Yes, my friends. So if the two variables x and y, what is their behavior? Such that if the value of y depends on the value of x, then this relation we name it as what? We say that y is a function of x, my friends. We denote, we call this relation between x and y. If the value of y depends on x, then we call it as what? Y is a function of x, written symbolically y equal to fx. In this reference, this is a dependent variable, whereas this is independent variable. It takes independently values. As we change x, automatically y changes. As we change x, automatically y changes. So x independent, y dependent variables. Yes, my friends. Yes, my friends. This is how function is given, its definition. Yes, my friends. Then comes types of functions. Types of functions. Yes, my friends. There are 4-5 types. One algebraic functions. Yes, my friends. Here, while doing, in general, we take it as what? X to the power n. Otherwise, what is this? It is a linear function ax plus b, fx equal to ax plus b, linear function, quadratic ax square plus bx plus c, quadratic ax square plus bx plus c, like that, man. Here, mainly in this man, we consider polynomial functions. It is in general what? X to the power n is a polynomial whose degree is n, x to the power n, polynomial function. Here also what? It is a polynomial function, but it is a linear polynomial function, quadratic, cube, with any degree. We take it as what? 1. Then is, my friends, constant function, C. Another is what? Normally we take it as what? One is irrational, which is root x. These plays matter, especially in finding the derivatives. What is the derivative of x to the power n? What is the derivative of a constant? What is the derivative of root x? We treat these as what? Algebraic functions, my friends. One it is. Second is trigonometric functions. I write in brief, trigonometric functions. In this man you have what? Sin x, cos x, like this. Sin x, cos ax plus b, like this, my friends. It is tan 3x, sec ax, cosec ax, all trigonometric functions, ratios comes. Any expression that contains trigonometric ratios, it is known as a trigonometric function. A function which contains trigonometric ratios, trigonometric function. Yes, what are the trigonometric ratios? Sin, cos, tan, cot, sec, cosec. Any function which contains these trigonometric functions, they are called as trigonometric ratios, they are called as trigonometric functions, man. Sin, cos, tan, cot, sec, cosec, all the six. Yes, my friend. Third one, exponential function. These are trigonometric. Next is exponential functions. In this case, we consider mainly one is e to the power x. What is this e, my friends? It is a fixed constant, exponential constant, lies between numbers 2 and 3. This e lies between 2 and 3, my friends. 2 and 3. And its approximate value is equal to 2.78. I am correct. Maybe. Okay. Approximate value is 2.78 e. It is a fixed constant between 2 and 3. It is a fixed constant. Then any constant other than 0, a to the power x. In particular, a may be e. A may be E in particular. It is any constant, it is a fixed constant. A to the power x, e to the power x, like that, man. Any function that contains this, what is A other than 0, any number? Yes, 3 to the power x plus 5 to the power 2x, like this. All these are, my friends, exponential functions. Exponential functions. Fourth one is logarithmic functions. Logarithmic functions. Yes, in this case, fx equal to, it is a function, logarithmic, what is it? It is log x to the base e, it is a fixed one. What is another function? Gx equal to, this is log x to any general base. I told about a, what is it other than 0? Yes, my friend. Gx is log x to the base a, fx is log x to the base e. Like this, when you can write any function connected with what these logarithmic functions. These are logarithmic functions. Logarithmic functions. Another is inverse trigonometric functions. It also comes here. Trigonometric functions and inverse trigonometric functions, that comes here. And one more, you are not studying this actually. It is there in engineering college, because now I am taking the classes for engineering. It is what? Hyperbolic functions, man. Hyperbolic functions. Hyperbolic. Now this is not there. You have to study algebraic functions, trigonometric functions, exponential functions, and logarithmic functions. This trigonometric functions, it also includes what? Inverse trigonometric functions, my friend. ITF. Inverse trigonometric functions. ITF. Yes, my friends. What these are? These are types of functions. Next, I want to tell functions are denoted. Functions are it is very normal. Why? Always. Like this, when we use what? Capital Fx. Like this. Gx, capital Gx, small hx. Even we use this also, my friend. This is phi x. This is psi x. I am giving in the beginning itself. At that time, if I write phi x, what is it? No. We denote the functions by these symbols. Fx, capital Fx, Gx, hx, phi x, psi x, like that, my friends. They denote what? The functions. They denote functions. Yes, my friends. See, I repeat once again. Started calculus, I told calculation, quantities, constants, variables, constants, arbitrary, absolute constant, variable, dependent, independent. I told what is dependent, what is independent. If you consider two variables x and y with a behavior, what is that behavior? If the value of y depends on x, this relation between x and y, mathematicians defined what? Y is a function of x. Written symbolically as what? Y equal to fx. X independent variable, y dependent variable. Then, my friends, types of functions, algebraic functions, such functions. Trigonometric functions having trigonometric ratios. Exponential functions, e and a, basis. What is e? It is a fixed constant lies between 2 and 3, approximate value given. What is this a? Other than 0, other than 1, other than 0, other than 1. Why? 1 to the power, anything is what? 1 itself is other than 1. Yes, my friend. It is any constant, it is fixed constant. Logarithmic differentiation, log x to the base e, log x to the base a. Again, these two bases plays a very important role. Any base or any number, it is a fixed number. Yes. This hyperbolic, my friends, it is not there for you. These are the symbols to denote what? Functions. Yes, my friends. Tell, what is your observation here? Sir, y equal to fx. Yes, I now definition of a function. Yes, my friends. Y equal to fx is a function of x. Y equal to fx is a function of x. Y equal to fx is a function of x. Yes, my friend. What is x? This is independent variable. Independent variable. My friend, y is a dependent variable. Dependent, I write in brief, yes. Dependent variable, yes, my friend. Written brief. Independent, dependent. See, my friend, variable. Variable means what? Values changes. One is a constant. What is it? No change. One is a change, another is what? No change. Yes, my friends. I will explain about it, man. About it. One. Yes, my friend. No change means what? It is a constant. In constant, there are two types: absolute, arbitrary. Absolute means what? These are fixed constants. Absolute means fixed constants. Yes, my friends. What they are? I told there itself 1, 2 like this, 1, 2 like this. Now I take one value x equal to 2. Yes, name itself. The value of x is fixed, it is only 1. The value of x is fixed, it is only 1. In this case, x is fixed. X takes the only one value. Changes. This changes in mathematics, yes, my friend. X tends to here. One more, they introduce another word, tends to. This plays a very, very important role. X tends to. I take 2 itself. This is 2. Yes, x tends to 2, x equal to 2. This is your number line, my friends. I take here because needs. Yes, this is your number line 2. This side is no end plus infinite. This side is also what? No end, it is minus infinite. This is your friend 2. This is what? X equal to 2. This is fixed. Tends to. What do you mean by tends to? What do you mean by tends to? Yes, ma'am. X tends to 2. X tends to 2. Tends to means it is an approach. Tends to means approach. In which sense approach? Approach means what? X approaches to. Yes, my friend. This is your 2. Now, x is 2, x approaches to. X approaches to means what is approach? Coming closer to 2. Approaches means what? X comes closer to 2. Then what are the values, my friend? If it is 2, approaches to means nearing to. Yes. X approaches 1.9 approach. Next it takes still closer, my friends. X approaches to means x comes closer to 2. These are the values which are very close to 2. Like this one, you can write how many values? Infinitely many values, not only 1 or 2, 10 or 100. How many? Infinitely many values. What is this approach? Here, your x takes the values which are less than 2. All this here, my friends, it approaches here, comes closer. Yes, it comes closer. It comes closer. This side. In this case, what? Values of x values of x less than 2. Less than 2. Even you can say, what is this? It is left of 2, left side of 2. Left side, left of 2. Left of 2. This man, values which are less than 2, we denote x tends to 2, or x takes the values less than 2 minus, or x tends to 2, this minus we write on the top, otherwise front. 2 minus means what? Values are less than 2, like this, 1.9, 1.99, like that, man. There are infinitely many values, x tends to 2. Now, what is this? X tends to 2 through left. Through left means what? These are the values of x which are less than 2. This we write symbolically as what? X tends to 2 minus means what? Through left. 2 minus, you mean through left. You mean x approaches 2 through left, taking only values which are less than 2. This is one approach. What about the second approach? What is the second approach? X tends to 2 this side. What are the values here? It is 2.1. It is 2.01. 2.0001, like this, my friends. It is 2.1. So many zeros, 1. What is this? All these are the values which are near to 2. All these are the values which are near to 2. See, my friends, tends to means x approaches. X takes the values which are very closer to what? 2. Closer to what? 2. What is your observation? X takes all values which are very close from left as well as from right, my friends, from right. But what about this? It never takes. Tends to means the values which are very close to 2 but not to 2. Very close to 2 but not to 2. My friends, x tends to 2 means either through this side or through this side. X takes all values in the neighborhood. You know the word neighbor, neighborer. A friend which very near to your house, means next to your house is a neighbor. Like this, what are these values? These are the neighboring values of 2. Neighboring values of 2. If you take the difference between what? Too many, so many zeros, 1 minus 2. What is the difference? The difference is a very small one. Here also, if you take what? 2 minus 1 point, so many 9s. What is the difference? It is point, so many zeros. Yes, what is this? A value which is very near to 0. It is a value which is very near to 0, but not 0, my friends. These are values. If you take the difference between this and this, absolute difference, modulus, either this minus this or this minus this, the difference is always a very small positive quantity, my friends. It is a positive quantity. It is a positive quantity which is very small, very small. Underline it, my friends. Therefore, approach means coming very closer to 2. It never, man, this friend x never takes the value 2, no, except 2, all very nearing values, means in the neighborhood of 2. Yes, my friends, this is what I mean by tends to. X tends to 2, x tends to 2 in 2 ways. What is this? Values less than 2. What about this side? This side is values of x greater than 2. Then x tends to 2 through right, my friends. Another way of saying this is through right. And the values are denoted. It is x tends to, my friend, 2 plus here above. Otherwise, x tends to 2 plus front or up, both. This is approach through right. This is approach through left. What is this, my friend? It is only one value. X equal to 2 means only one value. X tends to 2 means there exist what, my friends? Infinitely many values. Infinitely many values. These are values which are very, very near to 2 except 2. Then when x tends to 2 means x tends to 2 implies what, my friends? X never be 2. X tends to 2 means x never be 2. In this case, except 2. Except 2. This, my friends, except 2. Except 2, all values, nearing values x takes. Therefore, x tends to means x never be equal to 2. X never be equal to 2. When x is never be equal to 2, you can write what? X minus 2 never be 0. X minus 2 never be 0. See, never be 0. See difference here. 2 minus x never be 0. It is what? X minus 2 never be 0. Therefore, we have to take what here? Modulus. Modulus means what? It is x minus 2 or 2 minus x. The difference never be 0. It is a quantity, positive quantity, my friends. Remember, positive quantity which is very, very small. Which is very, very small. My friends, this is the meaning of what? Tends to. I hope it is clear. It is clear. Yes. I take in general a, small a, may be any real number other than 0 and infinite. 0 and infinite. Then x tends to a means x approaches a. X takes the values which are very, very close to a. If you take the difference is a very, very small positive quantity, positive number. Yes, my friends, it is yes. In general, meaning of x tends to a. Meaning of x tends to a means x approaches a and comes closer and closer to a. That is, x takes the values very, 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 very near to a. Yes, ma'am. I've explained much about it by taking 2. Okay. Then this is what? X tends to a minus or x tends to a minus means x approaches or x comes or x takes, I write only one word, x takes the values less than a, or we can say x tends to a through left. Yes, my friends, it is through left. Explained here. What is another one? X tends to. Another one. X tends to a plus here, or x tends to a plus anything means x takes values very near to a, very near to A, and values of x are greater than A, very near, greater than A. This is always very important, my friends. Very nearer to A but greater that side. Therefore, we say x tends to A through right. Right of A. Yes, my friend. Through right of A, from here, here, through right. This is through left, through right. Values of x less than A, this side less than A. Greater than A means what, this side, but nearer, greater than to these values. Neighborhood. Therefore, in all these cases, you can tell x takes the values in the neighborhood. That neighborhood, you may write it as what? X takes the values. Yes, my friend. What is it? One value through left. These are the values which are very near to A but less than A. Very near to A, less than A. What about this side? These are the values of what? X, which are very near to A but greater than A. Then x belongs to A minus H, A plus H. It is what? Near to A, taking smaller values of A, taking greater values of A. Then what about, my friends, your H? Where H is a small positive number or positive quantity. Positive number, small, very, very small. H is a small positive number or positive quantity, very small. These man, my friends, here it is there. This minus this one sample is left. Such a number is your friend H, my friends. This is what? The meaning of x tends to A. Again, see, my friends, your x will take all values very near to smaller, very near to greater, but not A in this case. X never takes the values. A except A. Therefore, x tends to A means, therefore, I have written here, x tends to A means, x never be A except this value. So, x minus A never be 0. My friends, one useful result, remember, tends to, here this, tends to. Yes, my friends, I explained about what tends to. With this man, here in this case, A never be 0 and A never be infinite. Even you can write here, meaning of x tends to A, I write here in the bracket, A other than 0 and infinite, my friends, plus or minus it comes. A is other than 0 and infinite. Yes, my friends. That is, x tends to 0 means, yes, my friends, meaning of x tends to 0. X tends to 0 means x approaches 0. Approaches 0. Approaches 0. And x takes values very, very near to 0. Very, very near near to 0, but not 0, my friends. This is important, but not 0. Therefore, x tends to 0 and x equal to 0, are totally two different aspects, means this is different, this is different. X tends to 0 means x never be 0. X tends to 0 means x never be 0. X tends to 0 implies x never be 0. Never be 0. This is one. What is another? Infinite. What is that infinite? Infinite is not a number. What is it? It is a symbol to denote an infinite increase. Yes, my friends. And indefinite increase in the value. Indefinite increase in the value of x. In the value of x is denoted by x tends to infinite. X tends to infinite, and an indefinite decrease. Indefinite decrease in the value. Decrease in the value of x. In the value of x is written symbolically or denoted by x tends to minus infinite. Therefore, from this, tell my friends, what is infinite then? From this it is clear. Therefore, infinity is not a number, but it is a symbol. It is a symbol to denote indefinite increase or decrease. What is infinity? It is not a number, but it is a symbol to denote indefinite increase or indefinite decrease. It is a symbol, my friends. Then I made it clear, my friends, meaning of tends to. Tends to means approach. Except that number, it will take all values which are nearer. That's very important. X tends to 2 means x never take the value 3, x never take the value 100, x never take the value 0, x never take the value 1. Which are the values? Which are the values which are very, very closer to 2? I gave the values, my friends. Remember, the difference must be very, 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 very less. This is 1. And then x tends to 0 means x never take the values 0. No. These are the values which are nearer to 0. So remember. Then infinite, indefinite increase, indefinite decrease in the behavior of x, written symbolically like this, my friends. 2 things. 2. X tends to 2 in 2 ways. What is this? X tends to 2 through left. Through left means what? Less than 2. Second, it is what? Through right. Through right means what? Values of x which are greater than 2. X equal to 2 is the only one value. X tends to 2 means it is a infinite set. Remember, my friends, this is the meaning. Somehow in the first year, sometimes we never explain in detail. It is explained, my friends. These are the main things we need in calculus. So that is why this basics, my friends, I made it clear. Yes, my friends. My next approach is about the value of the function. About the value of the function, that I do it in the next video. Yes, my friends. Thank you very much. I hope you have enjoyed with all these basics, my friends. With one we needed it. Thank you very much.